AI chatbots can sound completely confident while being completely wrong, and there's a specific reason for that. When a language model is trained, it reads an enormous amount of text and compresses all of that into a set of numbers called weights. Those weights are basically the model's memory of everything it learned. The problem is that memory is frozen the moment training ends. If something changes in the world after that cutoff date, the model simply doesn't know about it. It's like asking someone to answer questions using only what they read before a certain year. But the cutoff date isn't even the main issue. The bigger problem is that when a model doesn't know something, it doesn't always say so. Instead, it sometimes generates an answer that sounds right, but isn't. This is called hallucination. Hallucination happens because the model is always trying to produce the most statistically reasonable next word. It's optimized to sound fluent, not to be accurate. Those two things are not the same. Retrieval-Augmented Generation, or RAG, is one approach to reducing this problem. The core idea is simple. Before the model writes an answer, go find actual documents that are relevant to the question and hand those to the model as context. So instead of relying purely on what the model memorized during training, it now has real source material sitting right in front of it when it generates a response. It's closer to open book than closed book. The retrieval step works by converting both the question and all the documents in a knowledge base into something called vectors, which are just lists of numbers that represent meaning. Documents with similar meaning end up with similar vectors. When a question comes in, the system finds the documents whose vectors are closest to the question's vector. That's the retrieval part. It's a fast mathematical search, not a keyword match. Those retrieved documents get passed into the model's context window along with the original question. The model then reads them and uses that material to write its answer. Because the answer is grounded in actual retrieved text, the model can also point to where the information came from. That makes it much easier to check whether the response is accurate. RAG doesn't eliminate hallucination entirely. The model can still misread a document, retrieve the wrong one, or fill gaps with invented details. It's a meaningful improvement, not a complete solution. It also means the quality of the knowledge base matters a lot. If the documents in the database are outdated, incomplete, or just wrong, the model's answers will reflect that. RAG is already being used in customer support tools, internal company search, and research assistants where accuracy matters more than creativity. It's one of the more practical techniques to come out of recent AI development. If you want to understand what else goes into making AI outputs more reliable, the topic of prompt engineering and fine-tuning connects directly to what we covered here.